Greetings to everyone. The topic of our video today pertains to the groundbreaking revelations about the Arctic's Transpolar Drift, a dynamic current carrying Siberian river matter across the Arctic Ocean, unveiled in a Nature Communications study on April 14th, 2025, led by the University of Bristol. This research exposes the shifting pathways of nutrients and pollutants driven by sea ice and ocean currents. With climate change accelerating, these findings highlight the fragility of Arctic ecosystems and the urgent need to understand their future. Without further delay, let us delve into our discussion. Groundbreaking research unveils the Arctic's intricate pathways for matter, teetering on the edge of profound transformation as climate change intensifies. What drives the transpolar drift, this mighty Arctic current? It ferries sea ice, fresh water, and suspended substances from Siberian shelves across the central Arctic to the Fram Strait, a vital conduit to the Nordic seas. This flow shapes the delivery of natural elements, nutrients, gases, organic compounds, and human-made contaminants like microplastics and heavy metals from Siberian rivers into the central Arctic and North Atlantic. Such materials wield influence over Arctic biogeochemistry, ecosystems, and ocean circulation patterns. A dynamic environment, the Arctic Ocean defies predictability. Matter from rivers follows winding, ever-shifting routes, molded by fluctuating shelf conditions, ocean currents, and the life cycle of sea ice, its formation, drift, and melting. Swift and vast, this redistribution scatters both natural and pollutant matter across the region. Published on April 14, 2025 in Nature Communications, this international study, spearheaded by the University of Bristol, casts the clearest light yet on these climate-sensitive pathways. Led by Dr. Georgi Laukert, a Marie Curie postdoctoral fellow in chemical oceanography at the University of Bristol and Woods Hole Oceanographic Institution, the research reveals stark shifts in Siberian river water composition along the transpolar drift. Seasonal surges in river discharge, dynamic shelf circulation, and ice-ocean interactions amplify surface ocean variability, propelling riverborne matter far and wide. Sea ice along the transpolar drift emerges as a key player, not merely a passive carrier, but a dynamic force sculpting dispersal patterns. Unlike coastal ice, it traps material from multiple river sources during its growth, forming complex mixtures that journey vast distances. A revelation indeed. To unravel these pathways, researchers wielded geochemical tools, oxygen and neodymium isotopes paired with rare earth element measurements. This fingerprinting traced the origins of river-sourced matter, tracking its evolution over a year-long trek through the central Arctic. The data hailed from MOSAiC, the largest Arctic expedition ever uniting 7 icebreakers and over 600 scientists globally. Dr. Dorothea Bauk, a researcher at Kiel University, marveled at the findings. These year-round observations are unprecedented. Summer data alone once limited us. Winter ice was too formidable. This comprehensive interdisciplinary evidence unlocks deeper understanding of complex ocean systems and their future stakes. Yet, the Arctic is changing. Warmer temperatures shrink summer sea ice, reshaping circulation and drift patterns. Professor Benjamin Raab from the Alfred Wegener Institute and University of Applied Science in Bremerhaven warns these shifts could profoundly alter how freshwater and river-derived matter spread, impacting ecosystems, biogeochemical cycles, and ocean dynamics. The transpolar drift, first charted during Fridtjof Nansen's Fram expedition in the 1890s, is no steady stream. Over 130 years later, this study exposes its variability in space and time, challenging its image as a reliable conduit for river water. Dr. Laukert reflects, this iconic current is far from static. If it's so dynamic, the entire Arctic Ocean may be more fragile than we imagined. Though not focused on specific compounds, the research lays bare the transport mechanisms, a vital step toward forecasting Arctic matter movement in a warming world. As pollutants spread and polar ecosystems face growing threats, these findings sound an urgent call to action. To support our channel's growth and ensure broader awareness, kindly hit the like, share, and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.